Thanks for all the questions you've submitted so far. We've been getting lots of good ones in. And now we'll start with the first question for the speakers. For Dr. Boak, for Jerry, how much can Arbuckle injection increase under current restrictions? Where is all the Arbuckle injected water going?
First, I would say that it'd be very unlikely that there'd be a whole lot of increase. At present, virtually all the operators are capped at either 10,000 barrels a day in one area or 15,000 barrels a day in another area. And in many cases, they're very close to that right now. There are no new wells being permitted, so that's not likely to cause an increase. There was some concern that there was a lot of leeway, and that's what the latest action was intended to address. The actual amount that they could rise before it started hitting those restrictions, I would have to defer to the Corporation Commission on that, and I haven't actually got a number. As far as I can tell, the injected water that has gone into the Arbuckle, in essence, has spread, and we see some fairly long travel times, at least for the pressure pulse, driven by these by the water injection. I would say that it appears from the examinations we've made of the basement rocks, there's been plenty of opportunity for pressure to transmit downward into the basement, but not necessarily for a great deal of fluid flow. So I would say that what we've done is to reduce the underpressure in the Arbuckle kind of throughout the earthquake area of interest, by spreading.
Thank you very much. All right, the next question is any work being done to determine the seismic impacts on salt caverns, especially those used for storage of hydrocarbons?
This is Mike. Not to my knowledge in Texas whether that's being done.
All right. Well, thanks very much. We will move on to the next question. The city of Wichita is considering installing accelerometers in some major city buildings, and these data would be used to inform earthquake response plans and post-event structural analysis of potential damage. Would this kind of data be useful to researchers and regulators in your work? This asker is trying to establish the total value of any of the data they might produce in this project.
This is Jerry Boak. I guess I'd say we would certainly look at it. We've been working with schools to install accelerometers there, in part as an outreach activity, but also as an attempt to gather additional data on accelerations.
Yeah, and this is Mike. This is certainly something that we'd be interested in taking a look at. So I think there's quite a lot of value in that data.
Great, fantastic. Thanks very much. On to the next question. Are regulators considering requiring seismic monitoring at each disposal well, or are any regulators already doing this?
For here in Ohio, we currently don't have seismic monitoring as a requirement for every injection well. Basically what we do is it's generally done by a case-by-case scenario. We mainly focus on deep injection wells, ones that are going to be doing disposal in formations near the Precambrian, which has been our main focus. So for shallow injection wells, which here in Ohio tend to be Medina or Clinton wells, we generally do not have them put seismic monitoring out, but definitely for wells that are injecting in formations that are near the basement.
In Oklahoma, we've been focusing on trying to have a more comprehensive network of our own for monitoring, rather than having site-specific seismometers. Yeah, there are companies that have managed their own seismic network in the vicinity, particularly in the expanding area of the scoop and stack plays, sort of outside the edge of the seismically active area here.
And this is Mike in Texas, and to my knowledge, there's no move toward having a well-specific seismic monitoring program.
Okay, thanks very much, all of you. Next question is, if underground wastewater injection is causing these earthquakes, or many of these earthquakes, what are alternatives for the handling of wastewater, and what risks do they come with? And I'll leave that open to anyone who wants to take that.
Well, our produced water task force did look at a wide variety of alternatives: evaporation, treatment, and reuse or release. And but their cheapest options were the ones that involved direct reuse in the oil and gas industry, simply because there was less treatment involved. The risks involved in that are large-scale transport. Oklahoma disposed of 1.5 billion barrels of water in 2014 and 2015. So if you're going to transport any significant portion of that, you're going to have, there's the potential, depending on what your approach is, pipelines versus trucks. There are all of the hazards of those conveyance methods. And the largest problem that's caused less in the way of treatment has simply been the cost. If you've got in the plays that are responsible for the elevated seismicity are those that are very high water cuts, 20, 50, even more barrels of water per barrel of oil. And so the cost of anything but disposal looks, for the most part, prohibitive, with the possible exception of this reuse option.
Okay. Thank you very much. The next question is the Interstate Oil and Gas Compact Commission involved in developing any unified regulatory policies with regards to induced seismicity in its member states?
I'm actually not fully sure about that. As far as I know, the main outreach was through the States First Initiative, which was through multiple states, through information sharing and things like that. So that primer specifically targeted how to look at a unified regulatory policy. But at the same time, different states have different issues. So because of that, some things that work here in Ohio may not necessarily work someplace else. So because of that, definitely having a primer like this gives you the opportunity to at least get those ideas out and let other states be able to experiment with these mitigation techniques to help regulate any type of induced seismicity that we see.
Yeah, I'd second that. I mean, the primer was useful in terms of talking about what people were doing, but I don't think there's a move to standardize. It's clear that we have that, there are different thresholds, action thresholds with respect to completion practices, but the idea that you would have action thresholds is pretty widely accepted now. For injection, trying to understand the patterns of injection, where it's going, and what the effects are, is something we're all engaged in, but I don't know that we're yet to the point of evolving uniform best practices.
All right, thank you very much. We're going to just do one last question today before we finish up here, and that is, do you see a need for any changes to building codes associated with buildings constructed in areas close to wells? I'm assuming this question is specifically with regards to areas that previously did not have significant seismic activity.
It's challenging. Generally, the risk assessments done for building codes, as Jerry Boak, have been 50-year assessments. What's the risk over 50 years? And the USGS has said they're really not sure when they've done the two one-year assessments they've done, just exactly how this should be applied, because things are changing so rapidly. We've had a 30% decline between 2015 and 2016 in the seismic activity, and probably on target to have a 50% or more decline this year, depending on how things evolve. So it's hard to say you should start totally changing the way you build. Many of the requirements for, as I understand it from the structural engineers, many of the requirements for building strength that apply for tornadoes in Oklahoma happen to strengthen your buildings against earthquakes as well.
Yeah, this is Mike, and this question comes up quite a bit when talking with city managers and local officials, and this isn't something that we're recommending right now. Our role is really just to provide the data to the various stakeholder groups, and then the individual counties and city councils and things are looking into this. But to my knowledge, I don't know of any large-scale changes in building codes because of these induced events.
Okay, well, thank you very much to all of you who submitted questions. I think we'll stop there for the moment today. We have a lot of questions submitted. We'll send the questions that we didn't get to our speakers to see if they can answer any of those offline, and we'll send any of the responses to those around later. Thank you very much for staying with us. I know we've gone quite long here. I hope you really enjoyed this really informative webinar on a wide variety of state responses to induced earthquakes. That's about all we have time for today. Thank you everyone for your excellent questions, and thank you to our excellent speakers. If you have any questions that were not addressed today or that you haven't submitted so far, you can send them to us at cipinfo@americangeosciences.org, and we'll make sure to send your questions along to the speakers. We will be posting today's recorded webinar on the Critical Issues webinar page soon. You can visit the website to view this webinar as well as previous ones on a wide variety of geoscience topics, including in 2015 a webinar on induced earthquakes, particularly with a focus on Kansas and Oklahoma, if you want to get some historical reference there and some sort of basic information. Thank you very much, Jerry, Michael, and Stephen, for sharing your time, expertise, and insight. This concludes our webinar for today. Thank you for joining us, and we look forward to seeing you next time.